Orders concurrent.test is read again. Fire 10 checkout requests at once at a product with 5 units in stock, and exactly 5 should go through. Run it once, green. Run it again, green. Run it a 20th time and suddenly 7 orders succeed, and the stock column reads -2. We just sold inventory we don't have. The culprit is 9 lines in reserve stock. Read the current stock. Check it's enough. Write the new number back. Between the read and the write, a second request slips in, reads that same old number, and both of them think there's room. That's a classic read, modify, write race. It only shows up under real concurrency, which is why every unit test passed and production quietly oversold. So here's the experiment. Same repo, same failing test, 3 coding agents, and 1 rule: fix the bug, don't touch the test. Agent 1 is a plain autocomplete style assistant, the kind that finishes the line you're typing. Agent 2 is cursor working across files inside the editor. Agent 3 is Claude Code in the terminal with the whole repo to read. Each one got the exact same prompt. This concurrency test is flaky. reserveStock oversells under load. Make it pass 100 times in a row. By the end, you'll see who actually fixed it, who faked it, and the one habit that separated them. Takeaway upfront: the winner fixed the system, not the symptom. The autocomplete agent never left the function. It saw the failing assertion, saw a stop value going negative, and did the obvious local thing. It clamped it. Stock equals math.mex.0. Stock minus QWERTY. Now the number can't drop below 0, so the ugly -2 disappears. Rerun the test. The negative is gone. Looks fixed. It isn't. Clamping the number doesn't stop 2 requests from both passing the check. It just hides the evidence. 7 orders still go through against 5 units. The stock now proudly reads 0 instead of -2. It fixed the symptom on screen and never asked what the test was actually protecting. It never opened orders concurrent.test.ts to see that 5 succeed was the whole point. Fast, confident, and wrong in the most expensive way. It made the bug invisible instead of gone. Cursor did real work. It read reserveStock, correctly named the problem, a race condition, and reached for the textbook fix, a mutex. It pulled in async mutex and wrapped the recheck write in a lock, so only one request runs it at a time. Locally, this is beautiful. The concurrency test goes green, 100 runs, all passing. If the story ended on one machine, cursor wins. But the repo has a docker compose.yml that runs 3 replicas of the service behind a load balancer, and cursor never opened it. An in-process mutex only locks one process. 3 replicas each hold their own private lock. So the moment traffic spreads across instances, 2 requests on 2 different nodes race exactly like before. Right diagnosis, right instinct, wrong altitude. It fixed the bug on the node it could see and left it wide open across the cluster that actually runs in production. Claude Code did the boring thing first. It read the migration file, so it knew stock lived in Postgres. The compose file, so it knew there were 3 replicas. The test, so it knew overselling, not the negative number, was the real failure. Then it made one change. It deleted the recheck write-downs and replaced it with a single atomic statement. Update products set stock equals stock minus one-eyed is equal true, and stock greater than or equal to 1 returning stock. One query. The database checks and decrements in the same locked operation, and if no row comes back, the order is rejected. Now correctness lives in Postgres, the one thing all 3 replicas share. Instead of in application memory, each node keeps to itself. It ran the concurrency test 200 times, green every time. Overselling is now physically impossible, no matter how many instances you run. It fixed the system, not the symptom. Claude Code won, and the reason is one habit. It scoped the whole system, schema, deploy topology, and test before it wrote a single line. Cursor is a strong second. The diagnosis was right, and on one server the fix holds, but they never checked where the code actually runs. The autocomplete agent isn't a fixed tool at all for this. It patches what's on screen, which is great for boilerplate and dangerous for correctness. So use each for what it is. Autocomplete to finish lines you already understand. Cursor when you review the blast radius yourself, and the repo reading agent when the fix has to survive production. The pattern to steal is free and works with any model. Read the system before you touch the line. Here's the one that splits a room. If every test passes, would you let an agent's fix go straight to prod? Or does a human read every line no matter what? Take a side below. The arguments are where the next video comes from. If this made a difference, click, hit like, and subscribe. It genuinely tells me to keep making these. Next up, I hand the two losing agents the exact files Claude Code read and see if context alone, not a smarter model, closes the gap. Subscribe so you catch it.
I'm Sensei.
Go read the system.